Alright, final part. It is the extended response questions of 2017. Alright, hopefully if you remember from the lesson on Tuesday, yesterday, oh today actually, so late in the night. Yeah, the lesson I did today taught you how to use your CAS to find the maximum minimums and whatnot. It's pretty much this. You got 3 questions to do, and usually it's about 10 marks per question. But let's have a look at this problem, and we're going to use our CAS wherever we can, okay? So here we go. A piece of wire of length 120 centimeters. Remember how I taught in class? I said every line tells you something. So I would draw a line, and it says the length is 120 centimeters. So there you go. I got 120, 120, right? It is used to make a wire model of rectangular prism with a square base of side x, and then they're just telling me this is a square base. That's x, 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 so that's the area there, and height of y centimeters. So remember, I take 120 centimeters and I build this. Okay, so this thing here that I shape, bend it all around, this tells me that I can have each of the 12 edges is made from the wire. So they're really trying to tell you that, you know, I have 12 edges in total, and it's made of 120. So really, that there should tell you that it's not the perimeter in a 2D shape, it's the perimeter of the entire 3D shape should give you 120. So if this is y and that's y, this is x, 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 and there's, you know, if you look through it, there's another x up there. 4x is on the top, 4x is on the bottom. That's 8x already. Okay, plus how many y's? You've got 1, 2, and 3, but remember there's 1 in the back as well. So 4 y's should equal to 120. That's the first step that you should be able to do. You have to link the two together. The entire length of a wire builds this 3D. That's the first step. Once you've done that, now it just says find y in terms of x. So, you know, it's 4y equals to 120 minus 8x. Divide both sides by 4. What's that? That's 30 minus 2x. Bam. Got your answer. Okay? 1 mark. Next step. It says show that the equation of the volume. How do you find a volume of a rectangular prism? You know, equals length times width times height. That's what I would write. Anytime I read something, I write it down. Okay? You want to find the volume contained is given by. So they gave you the volume. Even if you couldn't figure this one out, you can use this and move on to the next question. Okay? So there's no excuses to just stop there and just not do anything. Use it. They gave you the equation. You can move on from here. If you can't prove it, screw that. 2 marks and get the next few marks from it. Okay? Now, let's have a look. How would you have proven that this is the volume equation? We know that the volume of a rectangular prism is length times width times height. Now, what's the length? It was x multiplied to what's the width? X again. Yeah, I'm just reading here. X times x and then times by y. But remember, it's all in terms of x in the equation. So how do I remove that y? Hopefully you've been watching my videos or you were in my class on Tuesday, which is today. This y value you can replace with this y. So if you do that, you get now x squared multiplied with y, which is 30 minus 2x. Okay? And you can see that 30 and 2 has a common factor of 2. Take it out. So it's x squared times 2 bracket 15 minus x. And that simplifies down to 2x squared 15 minus x. Voila. Done. Okay, 2 marks. Easy. Next one, write down the domain for this new function. So if you actually sketch this graph, you have to realize it's a volume versus x, which is the length. What's the problem with volume and length is that length can't be negative, so nothing on this side, and volume can't be negative. So if you draw the graph and it has like this bottom part, you have to ignore that, and you only take this domain from there, here to here. That's what you really got to find. You got to find that x-intercept. So the easiest way to do this is I would define that and then sketch it and then visualize it. Find the x-intercepts and that's my domain, right? So here we go. Let's go to your CAS. I would go back and I'm just going to clear, this is from the multiple choice section. Define f of x is equal to, what was it again? You had 2x squared multiplied to 15 minus x. Okay, there we go. That has no restrictions so far. So if I actually sketch the graph, now my graph looks like a quadratic, remember, but hey, look, if you see, if I move my cursor, you can see on the right hand side, I got another part of the curve. I taught you 3 things in the other video to adjust this window. I would say menu, 4, and there are only 3 things I want you to use. It was zoom box, zoom fit, or window settings. I will always do zoom fit first. So I go down to zoom fit, and there you go. See, it fits it nicely, but it's a bit too big. So I want to focus on just this section. Remember, the volume can't be negative, and neither could x be negative. So I don't need this left-hand side. So I'm going to go menu 4, zoom box, which is number 2. Zoom box. And the great thing about zoom box is you can focus on where you want. I just want from this corner to just past the x-axis over here. And I'm going to do that corner there. So I'm going to press enter. And isn't that much more beautiful? Look at that. Look at that graph. That's so much nicer. And all I did was zoom fit, zoom box. You can all do that. Okay, don't freak out. Don't try to do all these weird zoom in, zoom out. It looks terrible. My graph is 100% better than yours, and it takes only 2 steps. Okay, now you need to know the domain. Now the domain started obviously from 0, and it goes all the way up, and then it comes back down. Now volume is positive, so that's great. But up until this point here, volume is now negative. It's on the below the x-axis. So we need to know where that point is. So what you're going to do is go menu 6, 0 tells you the x-axis. So I'm going to move this over here. Let's find the x-axis, and it's 15, 0. So it tells me it starts off at 0 all the way to 15. Now, if you're unsure if it starts off at 0, again, you can do menu 610 and find out if this is 0, 0, and it is. Okay, so the domain starts from 0, 0 to 15, 0. So the domain is 0 to 15. So when I write my answer, it is 0 to 15, but remember, you can't equal it. Because if it's equal, okay, if it's equal, then the volume at this point is 0. How can you have a box that is 0 volume? That doesn't make sense. Okay, so that's why the graph, when you draw it, has to be an open circle. Don't forget that. I think every time I make a sack, you guys are forgetting that. Okay, so open circle for these kind of questions. So that's why when you're answering it, it's not equals to. X is greater than 0 and is less than 15, but not equal to. Okay, there you go. Next one, use calculus to find the maximum. Hopefully you've been watching my lesson from today. Maximum means, remember, you can only get a maximum or a minimum or point of inflection based on stationary points. That's the special thing about maximum minimums, right? And if you want to find it, it's the derivative, right? But I know even if I didn't use, they told you to use calculus, so you have to use it. But even if you didn't, it's up here. See, the maximum is obviously up here. You can just find the answer through menu 6, 3, maximum, and then just do that. The maximum, just in case it wasn't 1,000, I'd double check by changing the settings. Now, if you watch my applications video, yeah, mine's on float 7, so it should be all right. So yeah, the answer is 1,000. That's the maximum volume. Because remember, this is the y value. Y is 1,000 and x is obviously 10. Okay, so when the dimensions for the diagram, x is 10, so if you go back up here, if x is 10, then apparently that's when you have a maximum volume of 1,000. But it's not about answering that. You will get 0 if you just wrote the answer is 1,000. Okay, you won't get your answer as the volume because it says possible volume. You won't get the mark for that. You actually have to use calculus. So maximum occurs when the derivative equals 0. Okay, derivative equals 0. Now, what's the equation? We want the equation of the volume, but hey, they gave it to you. It's up here. They told you the volume is equal to 2x squared multiplied to 15 minus x. Okay, your goal is to find the derivative of this. Now, hopefully you've learnt from practicing, what I've shown you. This is part of your sack as well. You can use product rule. You can expand it to make it easy because they're all pretty easy to multiply. That's now 30x squared, and that's what? Minus 2x cubed. You can all derive this. dv dx, which is the derivative, derive this, that now gives you what? 2 times 30 is 60x minus 6x squared. There you go, that's my derivative. But what am I trying to find? I want to find maximum volume. Maximum volume occurs when the derivative equals 0. So here we go, 60x minus 6x squared. Factorize it, take out, don't move it across. Always factorize to solve, yeah? So we got 6, factor of 6, and you've got a factor of x, so there's 6x, factorize it, that becomes what? 10 minus x. So if you solve it now, x is equal to 0 or x equals to 10, okay? So using null factor law there, 6 times something, so that thing could be 0 and the whole thing will equal to 0, or 10 minus 10 gives you 0 as well. Okay, so x equals 0 or x equals 10. Now we know from before x can't be 0, so it can't be this one since x is greater than 0. Then that means x has to equal to 10. Okay, which is true because that's what I figured out over here. Remember with the cas, x was equal to 10. So therefore this must be the answer. So when x equals to 10, okay, I've got a stationary point. I don't know it's a maximum. You only know because I drew the graph and I did it on the cas here, but you have to prove it. So how do you know this is a maximum or not? Okay, you're going to have to test it. And hopefully you watch my exam 1. I showed you how to test it. This is x dy dx. This is the derivative. And then you got your sign. So when x is 10, you got to pick a number before and after and look at the gradients. You know the gradient at 10 is 0, so it's a horizontal line. Now pick a number. I'd probably pick a number less than 10. Let's pick 1. Okay, and let's pick a number greater than 10. Let's say 11, I guess. You got a calculator, so you can sort of plug it in and play. But since the derivative is equal to 60x minus 6x squared, this is what I would do. Go back to my calculator, and I would say define. Actually, I would probably do derivative. So define g of x is equal to the derivative of f of x. Okay, and I'm going to try sub in 1 into the derivative. That's 54. So I now know this is 54. And I know where g of 11. So I'm subbing 11 into the derivative. It's negative 66. So what that tells me is a negative gradient, positive gradient. Clearly, it's a local max because it's negative, positive. So remember with a local max, 0, this side has to be a positive, and on the right-hand side has to be a negative, and it's true. It's negative, positive, and 0. So hence local max. But I haven't answered the question. The question was find the maximum area, possible maximum area. So area is equal to, oh, not area, volume. Volume is equal to, now since you know at x equals 10, you get the max volume. Go back to your cas, then f of 10, sub 10 into the equation, and you get 1,000. You see, so x equals 10, then you can do 1,000 there. That's okay to do. Okay, if you get up to that point, you can do that. That's okay. All right, and there you go. That's answering the question. Voila. Okay, obviously they probably would have done it by hand and sub 10 into the function. Okay, and you could do that too. I'm just really trying to get you in the vibe of how to do these problems. Okay, look at the solutions as well, so you know how to do them. But anyway, sketch the graph. I already got it over here. Remember, control cursor, so control and move the arrow. There you go, you got your graph, and it kind of looks like that, right? But remember, it's open circles there. It's at 0 to 15, and the maximum was at when x is 10, volume is 1,000. Okay, so let's read it. It says sketch the volume of the function. So I got v against x, and over the domain, so 0 to 15, opposite on the x-axis below showing all its possible features. So I got turning point, endpoints. Voila, 2 marks, too easy. Okay, and there you go. Let's move to the next one. Same drill, guys, same drill. Define the next function. So it says plants grown from genetically modified seeds observe average height. So P, this is the height in centimeters. batch of genetically modified seedings, T days. So T represents days, so 0 to 120 days. Were planted out is given by. So I would define that equation straight away. So I'd go over here. What is this? How long you? Well, I mean, I don't know what that means. I'm going to read that email later. It looks like an important email. Anyways, here we go. Define f of x is equal to 2.8 times what, 5 to the power of 0.013 times x, okay, and plus 4. There we go. But see that there's a domain. It was 0 to 120, so hopefully you learnt how to use the given. So control equals, use the given symbol, and you know it's between less than or equal to x is less than or greater than or equal to, oh come on, there we go, 120. So I put a domain into it. So this is my, oh, it's hard to see the graph because I already got, let's do a new one. Control docs, add a graph, and then type in f of x again. And you can't see the graph, right? So what do? Menu, 4, zoom fit. And that kind of gives you a visualization of the graph, not the best one. What else can I do? It was 0 to 120. Oh, so now because it's 0 to 120, what I might do, you can use your cursor. So this button over here, if you hold it down on the screen, it should look something like you should be able to do this. See the hand? And then just move it across just to see if you can see it. Now, 120 is a bit further out here. So what I would do is I'd change it now Windows settings. So Windows settings. Now remember, we knew it was 0 to 120, the domain. So since it's 18, obviously you don't have it all. So I would actually go to 130 to accommodate for the width, but obviously it's not high enough. So I would then go to menu for 1, change the Y values because right now it's maximum of 7. I'd try 1,000. And it's all trial and error at this point. Okay, so I'm doing 1,000 was too high. You can see the value up here, it's much lower. So maybe I'd try menu for 1. Let's try, whoops, -1. Let's try 100. And that's a better graph. Okay, so maybe it's about 50. So you can try it again and go menu for, oh, actually instead of, do zoom box. Zoom box makes it easier. Do this and then over there. Second corner. Come on, corner. Give me that corner. There we go. Got a better graph. And if you just shift the graph a bit, maybe you get a better view. Okay, I'm just going to do menu for 1. I'm just going to adjust it a bit. Maximum, let's make it 45. And just a bit across. There we go. This is my graph. Okay, I like to visualize the graph first. Now you can play around with it however you want, but I was just showing you how I would have done. I define it and I sketch it. Right, now let's answer the question. It says, for how many days were the plants observed? Well, clearly 0 to 100 is 120 days. Too quick and easy. Yeah, if you really try to understand the problem, it was 0 to 120. These are the days. So you start at 0 days to maximum 120 days. So it's 120 days, yeah? What was the average height of the seedlings when they were planted out? Now, average height, it just means when you first started, what was the height on average? Because it says when they were planted out. So really when t equals 0, that's when you first started, what was the average height? Well, you can look at your graph and the average height is at this point. That's where they started before they grew, true? So you're doing f of 0 and it gives you 6.8. Okay, so it tells me the average height. F of 0, so at t equals 0, which is when they were planted out, is equal to 6.8. Is it centimeters or meters? Centimeters. That's my average height. Okay, next one. What was the average height of the seedlings 100 days after they had been planted out? Give your answer correct to 2 decimal places. So in this case, it's pretty easy. It's when t equals 100 days, so t equals 100, f of 100. Since you defined it, it's pretty easy. Go back to your CAS, f of 100. Now, it says correct to 2 decimal places, so that would be 26.69. 26.69 centimeters. See what I'm doing? Hey, too easy. 3 marks. All CAS. I haven't really done much thinking, have I? Next one, sketch it. Woo! Well, we knew it started at 6.8, didn't we? We said 6.8, and I drew the graph, and it goes kind of like that, wasn't it? From the graph, it was like something like that. True? Now, it says here, clearly on the graph the coordinates of the endpoints. So I know that at 0, it was 0 and 6.8, but I don't know what happens at 120. So when it's 120, what was the y value? Well, type it in. F of 120, and it tells me it's 38.47. It says correct to 1 decimal place. So if it's correct to 1 decimal place, it should have been 38.5. Okay, there you go. That's my height. And that's my endpoint. That's the shape of my graph. And that's about it. Doesn't tell me any asymptotes or anything. So technically there should be an asymptote at +4, but on the set of X, sketch the graph of the function P. Well, it doesn't say equation asymptote, so I'll probably leave it like that. That's what I would do. Okay, but that was quick and easy. Okay, now find the number of days it took for the seedlings to reach an average height of 10 centimeters. So now they're telling you, what if the height is 10 centimeters? Find the number of days. So really, in your equation, they're just telling you, what if this was 10? Actually, I just realized they used P, so all of this should have been P. P of 0, this should have been P of 100, and yeah, that should be all right. So they're really just saying P of T is equal to 10. Did I use X, by the way? No, I used T. Okay, cool. So P of T equals 10. And you want to find T, solve for T. Now on your CAS, it doesn't tell you that you have to use algebra or anything. On your CAS, just go menu, 3, 1, solve. Since you're ready to find X, f of X equals to 10, because that's what you wanted, height to be 10, solve for X. Bam, what do they say? Correct to the nearest whole number. So 36.4 is closest to 36. T equals to 36 days. Bam, too easy. Yeah, too easy. T is approximately what? 36.4265. Really? Can you really see the extended response question with my CAS work? Have I really been stressing my brains out? No, I haven't. In fact, I'm doing this much quicker than I did for Exam 1. Because Exam 1 was all theoretical and there was a lot of handwork. But look at what I'm doing. Learn your CAS. Trust me. Learn your CAS. You will be fine for the exam. Anyways, let's go for the next question. Find the average rate of change. You guys haven't actually learned this. It's not on the course anymore. So you can ignore it. But if you really want to know, average rate of change just means y2 minus y1 over x2 minus x1. It's the gradient. That's what it means, right? In our case, x1 is obviously when t equals 10 to t equals 60. So you want to know the height when it's 10 and when it's 60. So if you go back to your calculator and do f of 10, you get that, and then f of 60, and you get that, right? It says correct to 2 decimal places. So it is 7.45163, and the other one was 13.8255. Okay, if you were to solve this, then the average rate is equal to P2, because that's the Y value. This is Y and this is the X value. P2 minus P1 over T2 minus T1. So if you write it out, if this is T1, T2, this is P1, P2, you got 13.8255 take away 7.45163 all over 60 take away 10. That's essentially what you're doing. That's what the average rate means, okay? But if I were to do it, so this is how I would have done it. I would have gone to my CAS average. So in the numerator, it should have been 13.8 something minus, and I highlight this one, drop it down, and this one should have been 60 minus 10. Bam! They told me to round the answer off to how many decimal places again? It was to 2 decimal places. So that's what, 0.2 0.127477, which is approximately 0.13. Okay, that's the average. Centimeters, that's the height per day. Centimeters per day, that's the rate of change. Okay, but we don't do that anymore, so you can ignore that. Next one. These type of plants grown from genetically modified seed reach a suitable height for harvesting after the seedlings have been planted out for 100 days. How many days after the seedlings have been planted out would they have reached half this suitable height? Look, I'm actually really getting tired, but I'm not even focusing. Here we go. These types of plants grown from genetically modified seed reach a suitable height for harvesting after the seedlings have been planted out for 100 days. Okay, so it reaches some height out for 100 days. Okay, how many days after the seedlings have been planted out would they have reached half this suitable height? Okay, so first thing, they changed the domain from 0 to 120 days to now 100 days. And they're asking you, how long would it take to reach half this suitable height for harvesting? So I guess the question is, what is the height at 100 days? What is the maximum height at 100 days? Okay, because we don't know what the height at 100 days is. So f of 100. So that gives me, what, 26.6892. So P, when it's 100 days, I've got a height of 26.6892. But apparently the question is they want half of this suitable height, because that's what they were telling you. It's a suitable height for harvesting planted out for 100 days. So this is a suitable height, but I want half of that. So half of this height is, the question is, what time should it be? T, how long should it be before you get half of this? So divide this by 2. So I'm going to take this and say divide by 2. And I get 13.3446. 13.3446. But they're asking me how many days. So I need to find T, given that you got this equation. So you're really just trying to solve for T if you know P is 13.3446. So really you're doing solve for f of x equals 2, and I'm going to enter that in, comma x. Bam, there you go, 57.6. And it says round to 2 decimal places, so 57.60 days. There you go, quick and easy. Okay. A batch of the same type of plants but which had grown from non-genetically modified seed was also observed. The average height in centimeters of these non-genetically modified plants is given by, okay, so they give you a new equation. You got KT plus 4, okay, where T represents the number of days since the seedlings were planted out, and K is a positive, so that's a key word there. K is positive real constant, so it's positive and it's a number. The average height of these plants was 9 centimeters. Ooh, okay. 30 days after the seedlings have been planted. So they're really saying when T equals 30, P of T is, or P of 30 is equal to 9. That's pretty much what they just told me. Yeah, that's the key thing. You guys have to read the sentences and read what they're trying to say. They said the plant height was 9 30 days after they planted. So obviously it takes 30 days to reach 9 centimeters, right? So I guess to me, it sounds like you just need to solve this equation. If this tells me n is the height, because it says average height in centimeters, then height was 9 is equal to 2.8 times 5 to the power of k, k times t, which is 30 days, okay, and then plus 4. Do that in your CAS and solve for k. So solve k, which is 9, equals to 2.8 times 5 to the power of k times 30 plus 4. Solve for k. That was it rounded to 3 decimal places, so 0.012. 4k equals 0.012. Bam. Too easy. Am I done? Oh my god, another question. I'm too tired. What is this? You know what? I'm gonna stop because I'm gonna go pack up and go to sleep. Gotta wake up in the morning. But really, hopefully you can pick up what I'm really doing. I'm really not using a lot of maths for these questions, by the way. Can you see how I'm just using my CAS? The next question, I'm probably gonna do the same thing where I'm gonna define this, make sure I put it in the domain, and then read what this means. It's T hours after 8 a.m. So number of hours after. So if they said 3 hours, then it's obviously at 11 a.m. Okay? And keep that in mind and determine the temperature at 10 a.m. So from 8 a.m. to 10 a.m., that's clearly when T equals 2. Probably sub 2 into this equation. And then find the temperature. Yeah? And it's the same thing. So really define, solve. I really haven't done... If you look at all my calculator work so far, I've just been defining and solving and defining. I haven't done much else besides that. And that's all you need for your CAS. Okay? I'm going to leave it there. The solutions are up there, so even if you did struggle, you can probably look at it and work it out from there. But I hope these videos have been really helpful. I'm really sorry about Monday, but I do think this is a good start for you all in terms of like with the videos. It should help you enough to get it rolling for 2016, 2015. Now, on the camp, I will see if I have time because apparently I have some free time to do stuff. I will do 2016 as well. I'll record it and hopefully either get internet and I'll upload it, or when I come back on the Friday, I'll upload the 2016 exams, and then over the weekend I'll do 2015. But look, no promises here. I'm going to try to do my best for you to support you while I'm not here. But I really do think that if you can see what I like the videos, how I went through it, Exam 2 is all CAS. Please try to learn your CAS. Really, there's not too much to learn from the CAS. You can do it. Do it with the CAS. And Exam 1 is where it matters in terms of your algebra. And I know with our class, there are certain areas that we need to improve on. So some of us still struggle with fractions. Some of us still struggle with logarithmic rules. Got to learn those. Some of you still struggle with exponential rules, you know, like index laws. Your circular functions will need refreshing. So I think it's highly worthwhile. Look back at the past exams and look at the circular functions. See if you remember how to do those, or go through my notes again. Derivatives, I'm pretty happy. It's probably more likely to still be fresh in your mind. Don't worry too much about the application that you guys received or will receive tomorrow on Wednesday. Reason being is it is challenging, but having said that, that is the expected level for next year. That is the standard. It's not hard. It's just the standard. And as you can see, as I'm doing all these questions here, by the way, all the calculus stuff is very simple and straightforward. It's not too hard. Next year, though, you are required to really think. So that application paper that you'll be doing on Wednesday, session 6, it's worthwhile to get an idea of what it's like for next year. Okay. Otherwise, all the best. I don't think I will actually see you until your exam. Yeah, it's been a good year. It's been a good year. All right. Thank you. I'm going to stop the video here. I'm going to pack up my bags and get ready for tomorrow. See you.